Alright guys, this video is going to show you how to graph piecewise functions. So the first thing that we want to look at here is that this piecewise function has two pieces. And we see here several things that we need to look at. Over on the right side of those pieces we have what's called the domain restrictions. Those domain restrictions have elements that we need to make sure we know what they mean. So those elements, first of all, we have the symbol for infinity. We also have square brackets that mean you're going to include that point, or there's going to be a closed point, a closed dot on the graph. Other things that mean the point will be closed if it says equal to or greater than equal to, less than equal to. Then there's parentheses. Parentheses means it does not include that number, and so there will be an open point on the graph. Other things that include that mean not including or open points, if there's a not equal to symbol, greater than, or less than. So the first thing that I like to do is I like to take each function rule or each piece, and based on each piece I create a T-chart to help me with plotting some points. So in blue we're going to have x plus 1, and in green we're going to have x plus 3. And so for the first piece of this function, we see here that the domain restriction says from negative infinity all the way up to 2. And so I can use any point less than 2 that I can think of. So let's do negative 1, negative 2, 0, 1, and then we'll also do 2, but we'll have to remember that at x equals 2 there's going to be an open point because of the parentheses that is around this negative 2 or this positive 2. So you substitute the x values into the function rule. So negative 2 plus 1 is negative 1, negative 1 plus 1 is 0, 1, 2, and 3. And then we take our graph and plot those points. So at negative 2, our y value is negative 1, negative 1, 0, 0, 1, 1, 2, and 2, 3. But we must remember that at this 2, 3, it's going to be an open circle. We can then take our points, connect them, and then draw the arrow for infinity. So there's the first piece of that graph. The second piece, we take values from 2 to positive infinity, and we're going to include 2. So 2, 3, 4, 5 will give us a good direction for this line. 2 plus 3 is 5, 3 plus 3 is 6, 7, and then 8. So we'll plot those points and then connect our lines, and we'll have our piecewise function graphed. 2, 5, 6, 7, 8, connect them, do the arrow, and there is our piecewise function for this first graph. Our second function that we're going to look at is going to show us that we have two rules again, or two pieces here. This first one here is very, very simple. We have y equals negative 2 if x equals negative 1. So x equals negative 1 is here, and y is going to equal negative 2. That piece of the function is done. Now for the next piece, e to the x power, we need to substitute some values that are not equal to negative 1, or we need to understand that if we use negative 1, it's an open point. So we're going to have x and then e to the x power. So let's choose negative 1, and 0, and then positive 1 for our x values. Remember, if we use negative 1, this is going to be an open point. And if it's not linear, it's a good idea to use 3 or more points to make sure you get an idea of the direction of the graph. So when we plug in negative 1 to e to the x power, we have e to the negative 1 power is going to be equal to, it's approximately 0.4. And then e to the 0 power is 1. E to the first power is 2.7. So there we have approximated y values. We can plot some points. So negative 1 is approximately 0.4, but remember that's an open circle. X equals 0 is y equals 1, and then x equals 1 is y is approximately 2.7. So this here gives us an idea of the direction of this graph. And then we can graph this piecewise function. This function has now been graphed. And then here we have our last piecewise function we're going to look at. We have x minus 1 quantity squared, log base e of x, and log base e of 5. One thing that you guys need to know is that log base e of x in the calculator is the natural log of x. So this is the calculator entry that you'll use for log base e. And so if you look here at log base e of 5, that's actually going to give us natural log of 5 is going to give us a constant value. When you put that in the calculator, you're going to get 1.6, which means from 5 to infinity, my graph is going to be at a horizontal line of approximately 1.6. So 1, 2, 3, 4, 5, up 1.6. Now the dot is significantly larger than it needs to be, but that's just to draw your attention. And then 1.6 is approximately just a little bit above halfway up to 2. So there's our first graph, or our first piece of this function. The next two, we're going to use some t-charts. So the first one, log base e to the x, which is just natural log of x. And then we need to choose 3 points there. In this case here, we have 1 to 5. So we don't necessarily need 3 points, but we can go ahead and get all 3 points just so we can see the curvature of this line. So if we plug in 1, 3, and 5, well, ln of 1 will calculate to be 0. ln of 5 will calculate to be 1.6 because we've already done that. And then the natural log of 3 is 1.1. So when we graph these 3 points, we'll see the direction / curvature of this line. So we have 1, 0, 3 is 1.1, and then 1.6. So we connect these and you'll see that it's a bit of a curve. In the line. This is the natural log of x. This is the natural log of 5. And then we must do x minus 1 squared. So we'll take 3 points. Let's take points that got to be from negative infinity all the way up to 1. So let's take negative 1, 0, and 1. That should be just fine. Negative 1 minus 1 is negative 2 squared is 4. 0 minus 1 is negative 1 squared is 1. 1 minus 1 is 0. 0 squared is 0. So we'll plot those points. So we have 1, 0. And you'll notice some overlap here, and that's fine. We have 0, 1, and then negative 1, 4. Now you'll see a curve there. I also know that negative 2, when you plug it in, will give you 9, which will be 5, 6, 7, 8, 9 right there. And I only did that just to help me connect the curvature of that line. So this here is x minus 1 squared. And there's the graph of our third example. Guys, that's graphing piecewise functions.